Okay, so I had a request to do a couple problems, so here's number 14. So I'm going to let you take a look at it. Okay, and what it says is write the expression as one involving only sine theta and cosine theta. Okay, so there's something wrong with this because we can't have 2 theta here or 3 theta here, so we got to get rid of that. So the first thing that I would recommend doing would be to write this. Because we can write sine 3 theta, do you agree, as sine 2 theta plus theta? And then plus cosine 2 theta. So do you agree with this step? I can rewrite sine 3 theta as sine 2 theta plus theta. Okay? And then we remember our identity, and I'll put this over here on the side. Maybe I'll put it up here. That sine of u plus v equals sine u cosine v plus cosine u sine v. So you guys should remember that. Let me see here. Oh, right. Oops. There we go. Sorry, I'm having trouble with this. Okay, so you guys remember that. You can just look it up. Just remember that. So we are going to apply that identity, oops, to that right there. Okay? So do you agree with me that it's going to be sine 2 theta cosine theta plus cosine 2 theta sine theta. And then, of course, we have that plus cosine 2 theta on the end there. Okay? So you good with that? So all I did was I just rewrote this, oops, right there, as this, and then, of course, I have that cosine 2 theta on the end there. Okay? Now, again, we still have issues because I see a sine 2 theta, I see a cosine 2 theta, and I see another cosine 2 theta. So we need to eliminate those. And as you remember from your double angle identities that we talked about, let me flip back to them. So sine 2, well, how I taught it in class was sine of 2u equals 2 sine u cosine u. 2 sine u cosine u. Okay, so here's another, so I'll box this first one up here. Here's another identity that we're going to use in this problem. Right here, remember that? That's how we can do sine of 2u. It can be rewritten as 2 sine u cosine u. So let's put that in for sine, oops, on this side, let's put that in for sine 2 theta right here, okay? So we're going to end up with 2 sine theta cosine theta, okay? And then, of course, we're going to end up multiplying that by cosine theta, okay? And then we have the rest plus cosine 2 theta sine theta plus cosine 2 theta. All right? So that's where we are now, okay? So now our issue here is I see a cosine 2 theta. I see two cosine 2 thetas, all right? So let's see what we can do about that. And also the other thing is I probably want to simplify this cosine theta times cosine theta because you agree that I could probably write it as cosine squared theta, right? So let's simplify that. So now we end up with 2 sine theta cosine squared theta plus, okay, plus, so I simplified that. Now I need to rewrite cosine 2 theta. And if I remember, one of my other double angle identities was that cosine of 2u equals cosine squared u minus sine squared u. Okay, so this one down here is the last one that I wrote, number 3 right there. Do you see it? Cosine 2u equals cosine squared u minus sine squared u. Now we talked about how there were 2 other options as well. I mean, we can create any that we want, but I'm going to use this one, okay? I'm going to use this one. So let me replace it. So now I've got cosine squared theta minus sine squared theta, and then that whole thing, of course, times sine theta. And then I'm going to replace the second cosine 2 theta as well with cosine squared theta minus sine squared theta. Cosine squared theta minus sine squared theta. Okay, so all I did here, as you can see, is that I replaced the cosine 2 theta right over here with cosine squared theta sine squared theta, and I replaced the other cosine 2 theta with cosine squared theta minus sine squared theta. Okay? All right, so now what I want to do here is I'm having trouble doing this backwards. I want to multiply this. I could distribute this sine theta into this expression right here. So I'm going to distribute that in. Okay, so take a look at that right there. All right, and watch what happens. So I'm going to end up again with 2 sine theta cosine squared theta plus sine theta cosine squared theta minus sine to the 3rd theta, and then of course plus the end part plus cosine squared theta minus sine squared theta. Okay, so take a look at that. That's all I did was distribute that sine theta in. Okay, now look at what I've got here. Over here I've got 2 sine theta cosine squared theta, and look at this, sine theta cosine squared theta. So think of sine theta cosine squared theta as like x or something. So look at this, I've got 2 times x plus x. So do you agree I could write that as 3? So if I have 2 sine theta cosine squared theta plus 1 sine theta cosine squared theta, I could write that as 3 sine theta cosine squared theta. Okay, then once I've done that, I still got the sine minus sine to the 3rd theta plus cosine squared theta minus sine squared theta. So I'm just going to add that in. So minus sine to the 3rd theta plus cosine squared theta minus sine squared theta. Okay. And do we have anything, is everything in terms of sine theta, cosine theta? Okay, so we have some squares, but it's always just theta. It's not 2 theta or 3 theta or anything like that. So we're done. We've done what it asked us to do. Nice job.